In this simulation, we investigate the phenomenon known as total internal reflection. The idea is that for even transparent substances like glass and diamond, light can get trapped inside, reflecting rather than passing through to the air outside. This is related to Snell's law of reflection and some interesting mathematics. Let's see what's going on here. First, we can hit play and watch a light ray enter into, bounce around, and then refract out of a cut diamond. At the top of the screen, we see close-ups of the first two bounces and then the refraction out. The angles are labeled. When bouncing, the light obeys the law of reflection. The incident and reflected angles are the same. This is what we'd expect. On the final interface, when the light ray passes out of the diamond into the air, we see it refract. The incident and refracted angles are not equal. Well, how are they related? You might be familiar with Snell's law, which describes the relationship between these angles and the refraction index of air versus diamond. Since diamond has a higher refraction index than air, the angle in diamond must be smaller than the angle in air to obey Snell's law. We see that that's true in this refraction. Why does this occur? Well, the refractive index is related to the speed of light in a substance. In diamond, the refraction index is 2.42, much higher than that of air, which is only 1.0. This means light travels at a much lower speed in diamond than in air. This relates to the bending of the angle through what is known as the principle of least time. Check out our simulation least time if you'd like to learn more about that. Well, what happens at the first bounce? Why doesn't the light ray just refract out of the diamond instead of bouncing off? Well, if we revisit Snell's law, we see that the product of the index of refraction and the sine of the incidence angle exceeded 1.0. This means that the sine of the refracted angle would have to be greater than 1.0, which is impossible. No refracted angle exists, and this is the criterion for total internal reflection. You can adjust the shape of the diamond with the three sliders related to the depth, crown, and table size. Perhaps you can find a combination of sliders for which the light bounces back in exactly the same direction it came. That would be a pretty sparkly looking diamond. I hope you've enjoyed this video.